The data may arrive on time, but it doesn't have the level of veracity or integrity in which you can then confidently make a decision. So my question is now on the integrity side. So it's one thing to be fast. It's another thing to be fast and accurate. And I'll just share again, at NGA, I probably came a little late to this challenge because, and perhaps I spent too much time inside the family where, you know, everyone loves imagery. Who could possibly do anything bad to an image, right? Nobody would ever manipulate a pixel. Nobody would embed malware inside of it. That just wouldn't happen. And of course, it's been happening for a long time. It now can happen at a greater speed with greater impact given the enormity of and how connected we are. So anyone want to talk about the relationship between speed and integrity and the trades that might have to be made to make sure that you're not just on time, but you still have the level of data accuracy in which you can make a good decision?
If I may.
Please.
I can bring an experience that we have in that sense that is on the emergency side, that is closer to the defense stuff. We run the Copernicus Emergency Service since 12 years, so it's a long path. We have many cases. And what we have experiments, it's also, in that sense, the open-minding of the customers and the users, that they need a kind of information now, a better information in a couple of hours, the best information in one day. So let me say in an easy way, we can approach this problem in an agile way. So we can process and reprocess the data as faster as we can, but obviously the quality requires time, and the urgency requires velocity. So these two things are in competition, and the solution is to work in different streams, even with human in the middle, because sometimes we are thinking that artificial intelligence will solve the problem, but the fact is that we are looking at a very small area if we have the urgency. Otherwise, we are looking for a wider area if we don't know what we are looking for. The urgencies change. So this is the point. So we can understand which is the right pressure on the accelerator that we have to put to have a better quality. So this could be a way to approach today this.
Thank you. Thank you. Jimmy?
Give an interesting anecdote. So we do, as you probably know, our pipelines are completely automated, and then humans look at the final output. And when you do that, it's really important to keep looking at the final output and do idiot checks on it. So we ran into a case several years ago where one of our satellite providers actually changed the orbit of their satellite. They just moved it a little bit later in the day, and so the crossing times over the parking lots that we were monitoring was later in the day. Now, we already had normalizations in place for time of day, but those normalizations implicitly somewhere in the guts of the code made the assumption that once a satellite was in an orbit, it would never change orbits. Seems like a reasonable assumption. It takes a lot of fuel to change orbits. And we shipped that data, I think, to our customers for weeks before one of our data scientists realized that suddenly the peak of the images had moved about an hour later each day, and then went back and fixed the code. So I think it's a three-level problem. As Robert said, if there's an adversary putting crap in the pixels, that's serious. The pixels often have crap of their own. You know, just because there's light clouds, because there's snow on the ground, and it changes the radiometric normalization. And then just because there's bugs in the code, because you're looking at tens of thousands of lines of code, ultimately producing a small number of answers. So I think it's incumbent upon whoever's running these systems and the customers of these systems to do basically continuous idiot checks in multiple dimensions to deal with all these different kinds of problems.
Thank you.
I would like to add, talking about the integrity of systems, and the integrity with the operation also is a matter, actually. Today is getting the fastest data analyzed and processed, analyzed and interpreted in education, and then the reach and the dissemination. I think that's another integrity which need to be looked at today, and how the dissemination, maintaining the security and all of the other constraints also taken care of.
Good.
I'd add on the downlink side, today with the use of just going directly down to ground terminals, your data security and your time are almost directly at odds with each other, right? Because if you have one site that you really trust the security of and say it's only in Alaska, right, then you're going to have to wait a long time for that satellite to fly over Alaska. But if you're willing to use a site in Australia, you may hit it in 2 minutes, right? But then you have to use a terrestrial network, which may have more security vulnerabilities along the pathway to get it back to the end user. And so we're hoping to remove that with an in-orbit relay, right, where you could send it into our network. We're actually looking at using optical comm, which is even harder to pick up because it's such a focused beam, that you could take it directly from the imager to that specific site where you want to use the image without having as many vulnerabilities in that path. So we're hoping that that dynamic shifts over time so you can have both security and low latency at the same time.
The chain of evidence, if you will, would be more secure.
Yeah. It passes through less people's hands.